This collab covers PyTorch tensor operations, creation, manipulation, math operations, and GPU usage for deep learning. So first we import PyTorch and we check the version and shows if CUDA is available and GPU device name if present. So this code it lets us create tensors of different dimensions. Here we create a 1D tensor with a 5 number of elements. Here we create a 2D tensor which has 9 elements inside it. And here we create a 3D tensor which is a 2 by 2 by 2 matrix, and here it shows 2 comma 2 comma 2 as shape, 3 dimensions and 8 number of elements. Here we create tensors from Python lists showing D-type inference such as int64 for integers, float32 for floats in both 1D and 2D forms. So we also can do it with NumPy arrays. So here we set random seed and create a 3 by 3 tensor with a uniform distribution using torch.rand. So here it creates a 3 by 3 tensor with random integers from 0 to 9 using this torch.randomInt function here. And now we visualize our distributions. First is a uniform distribution, second is normal distribution, and third is the random integers. We have taken 10,000 samples uh, for this histogram. Here we create a 3D tensor 2 comma 3 comma 4 and demonstrate accessing shape, individual dimensions, and the numeral properties. So here are some D-type examples, the data types, which is torch, float 32, float 64, float 16, etc. So here we can see the basic indexing of 1D tensors. We first create the 1D tensor and then we give single element access. Then we use slicing. And we do the same for this 2D indexing. And this is for the advanced indexing, which is called fancy indexing with lists or tensors. So here we demonstrate basic tensor operations. The first one is element wise arithmetic, where operations that are applied to each element independently. So here we have used operations like plus, minus, multiplication, division on tensors. And here it also shows functions equivalent such as torch.add, torch.sub, torch.multiplication or division. So here we apply mathematical functions such as square root, exponents, exponentials, logs, log based on, or trigonometric functions such as sin, cos to the tensors. Plus we also round operations. We have also used round operations such as floor, seal, or round. Here are the aggregation functions such as sum, mean, standard variance, min, max, etc. So here this graph visualizes the dimensionality reduction with 2 by 3 matrix, showing us the sum dimension equals to 0, producing 3, resulting and with some dimension equals to 1, producing 2. Here we show broadcasting with scalar plus tensor and vector plus matrix, where the smaller tensor expands automatically to match the larger shape. Here the column wise broadcasting is demonstrated by adding 2 comma 1 column vector to 2 comma 3 matrix. Here we perform the in place operations such as the multiplication, sub, and division. Here we perform the reshaping of 1D tensor of the 12 elements into various shapes such as, for example, 3 by 4, 4 by 3, 2 into 2 into 2 using the dot view method. So like this we perform various other operations throughout the collab. Here we also perform some basic operations like the matrix transpose, sum over specific axis, etc. Here are the activation functions such as ReLU, sigmoid, tanh, leaky ReLU, GeLU, and these are all the graphs that we get from different activation functions. Here we perform softmax for multi-class classification. Here are the loss functions such as the MSE for regression and cross entropy for classification, etc. Yeah. And to summarize, that this collab provides comprehensive PyTorch tensor operations such as creation, indexing, maths, reshaping, linear algebra, autograd, and deep learning utilities.